Hello everybody, my name is Ahmed Essa, and for the Big Data Analytics course I used Google BigQuery to do my final project on. The reason I picked the topic is that I heard really amazing things about Google BigQuery, which seemed like too good to be true, like it can analyze 100 billion rows in 30 seconds. So the goal was to try it out myself and see what it can do. BigQuery is available via Google Cloud. It's a low-cost enterprise data warehouse, so you don't have to worry about managing servers or infrastructure. They also call it a serverless architecture, which means that you don't have to, when you sign up, you don't have to tell how many CPUs you need, the memory you need, storage you need, etc. All you do is upload your data and run the queries, and Google will automatically allocate the resources it needs to run the query. It is used for interactive queries and it is lightning fast. It supports limited version of SQL, which is really good because SQL is widely familiar. It has support for various client programming languages like C Sharp, Java, Python, and Scala. Once you create your schema, you don't have to worry about creating any indexes, foreign keys, etc. It is for structured data and it's an append-only database, which means you can just add data, but you cannot update existing data or delete existing data. So the problem I try to solve was something like, let's say you have a large structured data set that you need to analyze economically and you're familiar with SQL. I use publicly available movie lens data set that comes in various sizes: 100,000 records, 1 million, 10 million, and 20 million records. I loaded all those data sets in MySQL and BigQuery. First tried installing MySQL on my own local machine, but it didn't work too well for large data sets, probably because of my hardware. So I had to use MySQL on Google Cloud, and I picked a decent sized machine on the cloud for that. I then developed 4 benchmark queries and ran them in both environments. What I find out is that for if the data set is up to 1 million rows, MySQL is actually faster, but after you increase your data set beyond 1 million, BigQuery was faster. So find out that BigQuery scales pretty well. For the same query, if you're executing for a data set with 100,000 rows and a data set with 20 million rows, there's not much really a difference there. I also developed some sample client applications to access the BigQuery in Java and Python and generated visualization using Matplotlib. Find out that Python was pretty easy to use. Java was a little complicated, but the API was not that complicated. It was more like figuring out which jars to include and things like that, and looks like that's a one-time setup. So in addition, there are a couple things I tried to do but couldn't complete it. I tried to develop a simulator to generate financial transaction about 20 million a month. The goal was to have a year's worth of data in BigQuery that amounts to like 360 million, and use partitioning feature to see how well it behaves. And then the other thing I want to try is JDBC driver. I know most Java developers who work with databases are familiar with JDBC. There are JDBC drivers available for BigQuery, but they are pretty expensive, and that's why I wanted to write my own and see how that works. Let's talk about how to get started. So all you need is a Google account to get started, although the service costs, but if you provide your credit card number, they give you a $300 credit to be used, and it's valid for a year, and you can really do a lot with that. Also, don't worry about providing credit card information, because once your $300 credit expires, they don't start automatically charging your credit card. They will wait for that, and you will have to explicitly upgrade your service to be able to do that. Now, once you are signed in, you don't have to worry about creating your own data sets right now. They have some public data sets already available, which you can try out. One example is the public data about US names. It contains data from the Social Security Administration of all the names people selected. So we can use that. So let's give it a try. So these are the public data sets available in BigQuery. The one I was talking about is this one here. So this is the data set. These are all the tables within that data set. You click on that, it will give you some schema about that. So let's try to run some query against that table. Let's just see what's the how many rows are there in that table. So you can do select count this one here, and then you don't need the limit here. Oops. And then so that. So it's running right now, and took 1.9 seconds and tell me there are like 743,000 rows in there. So let's try to find out most popular male names for year 2015. I have the query out there already. It's right here. So it looks like a regular SQL with a group by clause. So if you run this one here, took like 2.2 seconds to run and was scanning 5 million rows, and it tells us that yeah, these are the top names in the US in 2015. So yeah, this is how you run it. And once you run the query, go to query history. It maintains like all the queries you have run. So let's start talking about the test data set. It's Movie Lens, and it can be downloaded from here. There are multiple files in there, but for this one I use only two of them, movies and ratings. The format is simple. The movies file consists of the movie ID, title, and what category it belongs to. It's pipe separated. And then the rating file has the user ID, movie ID, rating, and the time at which the movie was rated. So the next step is to try to get this information loaded. So you can import the data through the web UI, but it limits the size of the files to 10 megs. So I prefer loading the data through the command shell because there's no limit for that. So I'll show you how to do that. What you have to do is to install a program called Google Cloud SDK shell, and once you do that, it gives you an icon. You click over here, come over here, and then what you have to do is to use this command gcloud auth login. And what it does is that it makes you log into your Google account. So for example, yeah, this is the account I was using. So if I do that and I say allow, so it says now I am authenticated, which means that the shell is now associated with the Google account, and I can use the PK shell. So now next step is to create the data set. Then I can go from the presentation, copy the command to create the data set. It's MK Movie Lens, which is the name of the data set. So type this command, and that should create that. And now if you go back to BigQuery, do a refresh over here, this one shows up here. So now the next step is to create tables and load them. There's no it's not a two-step process to create the table files and load it all done in one. So this is the command to load the data. I will copy it here and paste it in the shell. So load is the command. Skip leading row says that ignore the first row. Movie Lens is the name of the data set. Movies is the name of the table it's going to create, and movies.csv is the file along with its full path, and the schema is defined along with this line. It did give us a warning, but it's probably a bad data in there, but let's see if the data is still created. So we can run the query from here, and yeah, it did get created. So there was just one bad data item in there. So that was one, and let's create the second table, which is the ratings. The same command, but this time I'm using a compressed zip file because it's a relatively bigger file and BigQuery doesn't upload first. So if you have a compressed file, that makes it go much faster. So I'm going to type the command here, very same thing. I'm specifying the table along with the in the command along with the schema. So first step is upload, the second step is create, and waiting for it to be created. Looks like it's done, and I can do a select now to see it's there. Let's start ratings. There you go. So the data is in there now. Now we can go back to the presentation. So now that we have loaded, the second step is to run some queries against that. My benchmark consists of 4 queries that I use, but just try 2 of them. So we can copy this query here and try this. This time, instead of going to the shell, we'll try it in the command. So go ahead and copy that, go back to BigQuery. So you want to compose a query. Paste the query here, run it. And it's running right now. Yeah, took 2.5 seconds and returned me the results here. So this is actually printing the movies that have been received the most number of ratings in that order. So displaying that. Let's go back to the presentation and try the second one as well. So this time this query shows you the number of ratings as well as the average review, but for only those movies that have received more than 50 ratings. Let's go back here, paste the query here, and run it here again. And it's running right now. Yeah, it took 2.6 seconds again. This time, yeah, it has the ratings, number of ratings, as well as the reviews. So these are my other 2 queries. I ran them similarly, and so this was just a quick demo of how actually I got this thing done. But what I really did was run these 4 set of queries in BigQuery against these 4 different type of data sets, and then use them in the MySQL as well, as try to compare to record the execution times and see how they compare. So let's look at query 1 here. As you can see, as the data size of the data set increases, the MySQL time is just taking too much, but BigQuery kind of remains flat. Initially, BigQuery was actually slower than MySQL, but once the data set got increased, it just could not keep up. Query 2 is the same way too. It's pretty flat here, and MySQL is straight line going up. Now query 3 is a little bit interesting here, because here you see even BigQuery is kind of like going up, although not in the same magnitude. So BigQuery is still better, but it's still going up. So I looked in the query here, and we were doing some complicated joins here. So I googled it up, and yeah, I mean it's not. I mean, if you have like one big table, it's better, but if you are doing joins, yeah, I mean you have to pay the price. But like you see, it's still better than MySQL. And then I have the 4th one here, kind of very similar to the other 4. So I also developed some client programs to connect to the BigQuery in Python and Java. This is the program in Python. Python one was actually the simplest to use. I'm truncating the query here, not showing the whole thing, but the idea is you connect to the client, you create a client which connects to the project, you specify a query, you get the query results, you run the query, and then you iterate through the results and print it back. One thing that you might have noticed in there is that I'm not authenticating or something. So just like you saw that I authenticated using the command line shell, that's enough, and then all applications are based off on that, and that actually seems like Google is recommending to do that rather than put authentication code within your app. Let's look at the Java program that I did. It's kind of the same, but as you can see, it's a lot more code out there compared to Python, but it's pretty intuitive and looks like it's all boilerplate code that you basically specifying the query, running it, getting the results, and moving on. One challenge that I have with Java is to find the right jar files to put in the class path. I did not use the Maven route. Looks like if you do that, that should simplify that. So I would highly recommend that. Use Maven. But in my case, I downloaded all the jar files myself, put them in the class file. It did work, but there was just one or two jar files that were missing. That took my time. One last thing, if you are a Java developer, you probably use JDBC to connect to other database. There are JDBC drivers available for BigQuery, but from what I could see, they're not free. They cost money. So I am in the process of writing a very simple, my own JDBC driver. Hoping that if I use it, that will simplify my code a lot. So if somebody really needs it or something, please feel free to keep in touch. I can share it with you. That's all I have for today. Thank you.